Alright guys, today we're going to start with solving systems algebraically involving one quadratic. This is Unit 3, Learning Target 2 that we're beginning. So I want you to first recall, when solving a system, what do answers represent? Answers represents the point of intersection between the two lines, and then the solution to all the equations. Okay, so how many times could a line intersect a parabola? Well, we could have a few different answers. A parabola, let's recall, looks like a U, or it can look like an N. Okay, so if I had a line intersect this way, that gives me two solutions because there's one point and there's one point where they intersect. If it went just like this, that would only be one point of intersection. Or if I had another parabola and then the second line just went this way, that would be 0 times. It doesn't intersect at all, so you could have 3 different solutions. Alright, so when solving a system involving quadratics, you need to follow these steps. You need to make sure both equations say y equals, and then you need to set the equations equal to each other and solve. So that's what we're going to do with example 1 here. As you can see that I have two equations here. I have y equals negative x squared minus x plus 6 and y equals x plus 6. Because they both are equal to y, I'm going to take this here, okay, so this one right here, and I'm going to plug it in for y right there. So I'm essentially just setting them equal to each other. So I'm going to take x plus 3 equals negative x squared minus x plus 6. Then I'll set this equal to 0, and I'll move everything to one side, and I will solve my equation. So I'm actually going to move everything to the left side so I can make my x squared positive. So I'm going to add x squared over here. I'm going to add x, make sure you combine it with like terms, and I'm going to subtract 6. So this side cancels out and it equals 0. I have positive x squared. X plus x gives me 2x, and 3 minus 6 gives me a negative 3. So from here, all right, to solve this now, we are going to break it up into our two parentheses, x and x, and because it's plus minus, that means my signs will be plus minus, where my bigger number is positive. The numbers that multiply to give me 3 are 1 and 3. If my bigger number has to be positive and my smaller number has to be negative, 3 minus 1 gives me a positive 2, and 3 times negative 1 gives me a negative 3. So I'll plug those in. You can see that x will equal negative 3 and 1. Again, if you can't work it out this way, you'll have to remember to use the quadratic formula that we learned in the last unit. Determining that what A, B, and C are. Okay. So that is how you get your answers. Once you do this, you will take your answers. So I have x equals negative 3 and x equals 1. I'm going to take these and plug them back into one of these equations, okay? It doesn't matter which equation I plug them into. I'm just going to pick one. So I'm just going to pick the bottom one here, y equals x plus 3. And I am going to plug in negative 3. So if I plugged in negative 3 plus 3, I get y equals 0. So when x equals 3, my point is 3, 0. Now if I plugged in 1, I get 4. So my other point would be 1, 4. So those are my two answers to this problem. All right, number 2, we're doing the same kind of thing. So whenever you see that they're already equal to y, you could just set them equal to each other. So I'm going to take x plus 5 here and plug it in for a y here. So I'd get x plus 5 equals negative x squared minus 3x plus 10. Again, I'm going to move everything to the left side to make my x squared positive. Add 3x to the other side and subtract 10. So I'm adding x squared, adding 3x, and subtracting 10. These cancel out. It equals 0. I get x squared. 3x plus x gives me 4x, and 5 minus 10 gives me a negative 5. So again, my signs have to be plus minus. So the numbers that multiply to give me 5 are 1 and 5. If my bigger number has to be positive and my smaller number is negative, 5 minus 1 gives me a positive 4. So I'm plugging those in here. So my x equals negative 5 and positive 1. Now I'm going to plug those into one of the original ones. I'm just going to choose the second one because it's a little easier. So I get y equals negative 5 plus 5. Well, y will equal 0. So 1 point is negative 5, 0. Now plugging in my other x value into the same equation, y equals 1 plus 5. So y equals 6. So my other point is 1, 6. There are your two answers for example 2. All right, looking at example 3. So if I look at example 3, they're not set equal to y. So I'm going to go ahead and set them equal to y, and I would need to do this with both equations. So if I take this first equation, I'm just going to add 6 to the other side to solve for y. So I get x squared minus 5x plus 6 equals y. Now I'm going to do it with the second equation. To solve for y, I'm just going to subtract x from both sides. So I get y equals negative x plus 3. So now I'm just going to take what y equals here and plug it in for y right here. So I get x squared minus 5x plus 6 equals negative x plus 3. Now I'm going to take my negative x plus 3 and move it to the left side. So I would get x squared negative 5x plus x gives me a negative 4x, and 6 minus 3 gives me a positive 3 equals 0. So seeing now what this will factor into, it's a negative and a positive, so my signs will be both negative. And the only thing that multiplies to give me 3 is 1 and 3. If they both have to be negative, negative 1 times negative 3 will give me a positive 3. And then negative 1 minus 3 will give me a negative 4. So I'll go ahead and plug those in. And x will equal a positive 3 and a positive 1. Now here, I would just go ahead and plug them into where you've already solved for y. Okay, so right here, I'll use this one. And I'm just going to use 3 first, so y equals negative, and then plugging in my 3 plus 3, so negative 3 plus 3, y equals 0. So 1 point is 3, 0. For my second one, I'm going to plug in 1. So if I plugged in y equals -1 plus 3, -1 plus 3 gives me 2. So if y equals 2, my second point is going to be 1, 2. And these are my two answers right there. Okay. Moving on to example 4. Again, neither of these are set equal to y, so I'm going to start setting them both equal to y. I'm going to start with this first one. I got y plus 1 equals -x squared plus 3x. I'm going to subtract 1 from both sides to solve for y, trying to get it by itself. So I get -x squared plus 3x minus 1. Remember, it needs to stay in the form of ax squared plus bx plus c. So x squared first, then our x, and then just our number equals 0, so it equals y. Then for the second one, I have y plus x plus 1 equals 0. I'm going to subtract x and subtract 1, so y will equal -x minus 1. And I am going to take this right here, what y equals, and plug it in for y right here. So I have -x minus 1 equals -x squared plus 3x minus 1. Now I am going to move everything to the left side, so my x squared is positive. So adding x squared first, subtracting 3x on both sides, and then adding 1 on both sides. So everything cancels out on the left side, and I equal 0 now. I have a x squared, -x, so -1x minus 3x will give me a -4x. Then -1 plus 1 gives me 0, so I just have x squared minus 4x. So when you have something like this, you have to remember that you need to do the greatest common factor first. And even though I don't have any numbers as my greatest common factors, I do have x's. They both have an x in common, so I'm going to pull out an x. So if I took an x away from x squared, I'd have 1x left. And if I took an x away from -4x, I'd have -4 left. So you have to recall that this gives us two solutions here, where our obvious one is a +4, and then the other one is x equals 0. So now I need to plug both of these equations into one of them. I'm just going to use this one right here. So y equals negative, and plugging in the 4 minus 1, so -4 minus 1 will give me a -5. So my first point is 4, -5. My second point, I'm plugging in 0, so y equals -0 minus 1, so -0 is just 0 minus 1, y equals -1. So my second point is 0, -1. And those are your 2 points of intersection for example 4. And that is all for these notes. So just combining some things that we learned the other day and solving for points of intersections. Remember, there doesn't always have to be 2, and sometimes that you might have to use the quadratic formula that we talked about right here. That was in the last units. Okay, if you have any questions, just send me a message. Otherwise, have a great day.